This conference will now be recorded.
Well, hello everyone. Brian Gockel here, Weather Service Office of Observations with the Tower West team, welcoming you to the Satellite Book Club seminar. In a moment, we'll be hearing from Joseph Patton, but first, just a few routine reminders. You heard that the session is being recorded for the benefit of folks who might listen later. As usual, we'll have question and answer after the presentation. Please post your questions in the chat room as we will be fielding them from there. And we're particularly interested in hearing from the folks from the forecast offices and regional headquarters, folks close to operations. We are very interested in your questions, comments, and feedback. As usual, we're looking for future presenters. So if you have a topic you'd like to share or are considering sharing, please contact the Tower West team and we could work with you to develop something. And as usual, the training team can help prepare training materials, whether they be for the seminar series or longer term. Please contact Brian Mata for information regarding that. Thanks go out to the Tower West team, in particular Kashad Bowman, as well as his coworkers for putting this together. The Office of the Chief Learning Officer, Weather Service Training, GOES-R JPSS programs, and to our facilitator, Chauncey Schultz, who is agreed to facilitate again. Chauncey's with the WFO Bismarck. So a couple things about Joseph's background. Joseph Patton is an assistant research scientist with the Cooperative Institute for Satellite Earth System Studies at the University of Maryland, College Park. He focuses on lightning research and training. His current position involves studying operational forecasting techniques using the GOES Geostationary Lightning Mapper and creating training materials based on lightning info from the GLM for forecasters within the Weather Service and around the Western Hemisphere. Joseph graduated from the University of Oklahoma in 2015, where he did his undergraduate work in meteorology, and then went on to earn a Master of Science in Meteorology from Florida State. He served as an operational meteorologist with WFO Goodland, Kansas for a while before joining the CISESS Cooperative Institute here in the DC metro area. Joseph, as we pass the microphone to you, to begin your talk, we want to welcome you back to the Satellite Book Club series.
Well, thank you so much for that wonderful introduction, and it's a pleasure to be back here. This is always a fun place to discuss ideas and talk about all the things that are going on with satellites. So today we're going to be taking a look at some GLM false returns. We're going to talk about what causes some of these false flashes, and also look at how those flashes manifest themselves in the gridded imagery so that operational forecasters may have a chance to recognize them and then overcome any complications those may introduce to whatever convective weather watch you're undertaking at the moment. So first, the good news. The good news is that the GLMs are really good at detecting bright lightning flashes. Some studies have reported that the lightning detection efficiency of the GOES 16 GLM was as high as 97%, and the GOES 17 GLM was as high as 93%. Some studies have shown it to be slightly less than that, but almost all the research has shown, that you're well exceeding the 70% full disk instrument requirement for detection efficiency across the GOES GLM domains for both of GOES East and GOES West. But that sometimes can come at the price of picking up a lot of false alarms as well. So because the GLMs are really good at detecting these bright flashes of light, some of them may be coming from non-lightning sources, and it may be difficult to filter those out, especially when you have to introduce more and more processing in real time. So the GOES 16 GLM lightning false alarm rate from that Bateman et al. Study in 2020, the one that had the good detection efficiency, also found that the false alarm rate of 0.06 in GOES 16 and the false alarm rate of 0.19, which is quite high in the GOES 17 GLM, that exceeds the target rate of 0.05 or 5% false alarm rate. So that means that the GLMs are picking up a lot of things which may not necessarily be actual lightning strikes or corroborated by ground-based or other observation networks. And so we want to talk a little bit about what those look like. So as an example, this is one of the false flashes known as sun glint. So sun glint, you basically got bright sun, usually reflecting off of a calm body of water or some other sort of reflective surface, and that transient bright flash of light can sometimes even be mistaken by the GLM for lightning. So in this image, if I can get it to animate. Well, it's not going to animate right now, but essentially what happens is the bright flash of light comes over here over the Amazon River Basin, and that manifests itself as some GLM false flashes. So we'll move on to some more examples. So some of these false flashes from the GLM are not actual physical sources of light. Some of them can be kind of referred to as ghosts in the machine. And this imagery is example of one of those ghosts in the machine that's commonly referred to as a hot pixel, where there may not necessarily be actual lightning going on in that area, but for whatever reason that we'll get into, that just one particular pixel keeps reporting lightning for one particular pixel on the GLM. But proper filtering can help mitigate these issues, and they've been made less prevalent over time. But understanding the causes of any false returns that still do make it past these filtering can help forecasters interpret them in operations. So a quick look at previous training on GLM false returns. Some data quality quick briefs and quick guides were produced in 2018 and 2020 by Scott Rudlowski and myself concerning the main sources of GLM false flashes, how the GLM data quality has evolved over time, and additional considerations in terms of uncommon scenarios which may influence the detection efficiency of the false alarm rate of the instruments. But we felt that there's a need for more or updated training specifically on the GLM false flashes, and also a broader look at data quality in general for the GLM. So the main sources of GLM false returns, if you boil them down to sort of a top list in order of how prevalent they are, this would be the list that Scott and I and with a few others kind of narrowed it down to. So the number one most common one would be what's referred to as a radiation dot. Just a random pixel that's not actually lightning, but it's just a single pixel and it doesn't last for very long. And they go down all the way from there through these different events. And we're going to get into what each one of these looks like, so we'll not spend too much time here. So let's go right into that first example, radiation dot. So it's a short-lived single pixel false GLM return, and it appears kind of randomly in space and time. And it's caused by high energy particles incident on the GLM focal plane. Basically, the GLM instrument is mistaking this high energy particle for lightning when it intersects the GLM focal plane. So these single group flashes are being removed to help mitigate this artifact, and that's referred to as the radiation dot filter. So if you see a random pixel kind of flash by itself, it could be one of these radiation dots and not actually lightning. And it'll often have a very low flash extent density of just one flash, because that radiation dot by definition is happening at one time. So the GLM would categorize it as an FED of 1. So that's one way to recognize it. That hot pixel the example we showed earlier is one of our most common GLM false returns as well. These inherently underperforming pixels are just intrinsic to the GLM CCD, and sometimes that results in hot pixels, and sometimes that results in dead pixels or cold pixels. This particular hot pixel was observed in the South Pacific in August and September of 2021. And we can go in and have some sort of second level threshold that can airbrush out these artifacts. But some of that, some of those eventually get filtered out without any intervention, and some of them it takes a little bit of quality control on the processing side for someone to say, okay, this is a hot pixel, we need to do some sort of additional filtering for that particular location. And those background radiants and thresholds are higher during the day, which disguises some of that noise from the hot pixel, making that artifact most prevalent at night. So it might be more illuminated at night than it would be during the day because those background thresholds are higher with the brightness during the day. Another example of false return is sun glint. So this is what I was trying to show earlier with that imagery in the Amazon River Basin, but it's basically sunlight reflecting off calm bodies of water, or even sometimes man-made structures like solar farms. The imagery that's playing at the bottom in this animation is from a solar farm in Southern Carolina, and you can see the sun glint light up a series of solar farms as sunlight is bouncing off of the bright panels, solar panels. And in 2019, the GLM reported those as false flashes because it was seeing these bright flashes of light. And that even had like a cascading effect as well. But a blooming filter has been applied to reduce the amount of false alarms. Even if it does momentarily see a false alarm, it won't cause that large cascade like we saw with 2019. So this is one really good example of a physical manifestation of a false flash that has become much less prevalent over time with better filtering being applied to the processed flashes of the instrument. But some of them are still going to remain. A couple of those trouble spots are the GOES 16 over the Amazon River Basin, like we talked about earlier, and then GOES 17 over Gulf of Mexico. So it just may be a good idea to keep that in the back of your mind that sometimes you may see some false flashes happen, especially when you've got sun glint happening with the right solar angle to shine light back at the instrument. And you can see it clearly on visible too, which is a good way to verify. So yeah, these were caused by solar farms, but it's been removed in imagery taken from the exact same time of day and date of the year, but just a year forward in time. Okay, so the next most common one would be what's called solar intrusion. So solar intrusion happens when numerous transient false flashes occur during the eclipse season. And the eclipse season generally runs from late February to mid-April, and then again from late August to mid-October. So during that eclipse season, the GOES instruments are mechanically blocked from viewing the sun during periods where the Earth is lining up between the instrument and the sun. So that causes a temporary regional ABI outage when the ABI is mechanically blocked from viewing the sun during these periods. And the GLM is staring straight at it, so sometimes it sees this transient passing of light and it mistakes it as a false flash. So this imagery is an example. Oh, I hope this one isn't doing it as well. It should be playing. But this imagery, if you would see it, it would sort of light up like a Christmas tree all the way up around here. And at the same time, the channel 13 IR blacks out, goes through a temporary regional outage. So that imagery would produce something which sort of is obviously fake because you've got all these different GLM pixels lighting up at one time. And some of the FED values would be very anomalously high. And, I kind of say that it looks like the lights on a Christmas tree. And it would also be accompanied by that temporary regional ABI outage. So that's one way to recognize that those might be some false GLM flashes. Oh, there we go. So you can see this imagery, it's got, if it'll play again. It played once. Yeah, but you can if you saw that, you would see, yeah. So there's those bright flashes, those that all those lit up pixels are also followed by that blackout in the ABI products as well. So the next most common one, a lot of forecasters in the U.S. have seen this a lot. This is the Bahamas Bar artifact, or even the inverse Bahamas Bar artifact. So what started out as false flashes being detected along certain subarray boundaries, especially when clouds were present around local noon. There was a filter applied to try to get these anomalous, erroneous flashes filtered out. But that's sort of resulted in what's now known as the inverse Bahamas Bar artifact, where it's just evidence that this second level threshold has been applied to sort of reduce those trouble spots of certain subarray boundaries. But they both occur with similar solar cloud conditions where you've got clouds present around local noon. And this is an example just off the coast of Texas in the northwest Gulf of Mexico, where you can see that line of flashes that looks like it's kind of been cropped out. And this one, a lot of forecasters see a lot because it's originally, it got its name for being a line extending into the Atlantic Ocean from the Bahamas. So, a lot of forecasters along the East Coast could also see that manifesting itself. This is just one thing to keep in mind as a forecaster, that, if you see something that doesn't look physical, like this weird line that's been cropped out, probably a good chance that it's not something that's actually physically happening in the lightning. Another possible example of false returns would be bolides, or exploding meteors, or objects that are bright coming between the instrument and the surface of the Earth. Anything that's going to be reflecting, any physical object that could reflect light back at the GLM instrument. So the GLM detects that sudden brightness of light, especially if something is irregularly shaped and rotating. You would see bright flash, darkness, bright flash, darkness, bright flash. And you can see that manifest itself in the GLM, both level 2 products and the gridded imagery. But those objects could be meteorites, they could be just space rocks that aren't necessarily exploding, they could be other satellites, and they may show up as like a long streak across the gridded imagery, especially if it's an object that's maintaining its altitude. But if it's something that's crashing into, like say a meteorite that's crashing into Earth and exploding as it does so, which happens fairly regularly, that may show up as just like a single pixel or just a couple pixels that light up as that. It's only in the plane of the instrument for a small amount of time. In this particular example, we had some sort of object. You can see it's rotating because you get bright flash of light, darkness, bright flash of light, darkness, bright flash of light, darkness. And it's got this weird streaky pattern to it. If we were to try to look at what this looks like in the gridded imagery, this is what it would look like. So let's hope this plays here. So it's, again, I'm having trouble with the animations here for some reason. But it basically shows up as this one long streak in the GLM gridded imagery that extends for hundreds of miles long. And that streak would be, it would look unphysical. And if you were to look at the values of the gridded products, they wouldn't necessarily be cohesive with each other. So if you see something that looks like a streak across that, it could be some sort of space rock or satellite, or some sort of bolide. And that could serve as a good way to confirm if the public sees something interesting and reports something interesting. You could say, yeah, the GLM saw that on our gridded products. And this next example is a really good example of that. So this was a bolide that was detected by the automated NASA bolide detection algorithm, and I've put the link in there as well if you want to go check it out. But it's not necessarily up to date. There's some processing that has to happen. But this is a bolide that was detected by that algorithm just off the coast of Florida, and you can see how it manifests itself in the GLM graded imagery as just one flash, and then in FED, so it's got low FED. It's got a very small minimum flash area, which would make sense. It's from a small area, and then it's got a very, very bright TOE. So you have this bright exploding meteor in the sky, and if you were to, and there were lots of people who could confirm this event because it happened next to so many populated areas. And this, hopefully this video plays. Let's see. But this is a video of basically a news camera, a news group, a cameraman and a reporter were out filming a story. And as they were filming the story, this giant fireball lights up in the sky. And it happened to be this exact bolide that was captured from this incident. I apologize about the animations. I've never had that kind of trouble before. Anyway, we'll move on. One other source of spacecraft instability, one other source of false returns could be spacecraft instability. Temporary GLM outages or false returns could be caused by orbital maneuvers such as the yaw flips, which are done twice a year with GOES 17, or any other sort of satellite repositioning. And messages about possible outages or spacecraft disruptions are typically shared by OSPO at their website. And here's an example of what those messages might look like. This is from June of 2021. And it just, it's a way to say, okay, so sometimes false flashes can be caused by, something that's out of my control, that's going on with the spacecraft maneuvering. And then the last one that I want to talk about for this talk is a pretty rare one called the rebound event. And what happens is that you get these abnormally bright and sustained flashes, which cause undershoot in the pixels aligned radially towards the nadir from that flash. And what that does is it can generate false returns in those pixels after the original flash ends until the background average of how many events the GLM can handle recovers. And it's not sort of, I don't want to say like it's blinded by it, but it's what you get is you get these false flashes down radial. And so you can see that these flashes here, this is the flash skeleton plotted basically from the raw flash data, courtesy of Michael Peterson. And this animation is our event intensity from each of those 2 millisecond frames, animation from Clem Tillier. So thank you for that. But you can see that here, our tail here is kind of where the false flashes are occurring, this little jet outside the edge of the cloud itself. And how would this look in terms of graded imagery? Well, the false GLM returns can often signify the occurrence of long continuing current. And they're also most common at night, where you have the dark background, and they're more common with the GOES West or GOES 17 instrument as well. So in the graded imagery, you can see kind of this weird unphysical spike in all the graded imagery products. We've got a large flash with low flash extent density and this weird kind of streak of moderate brightness in TOE. But these are fairly rare. So these are not going to be something that you'll see every day in operations. But this was one event that we were able to capture where we knew that some of these flashes were not actually physical lightning. So in terms of future data quality training, imagery and content and any feedback we get from the group from this presentation will likely be the basis for future data quality training on the GLM. We're considering doing another quick guide or quick brief, but we're also considering doing something that's a little bit more interactive. One of the ideas we've thrown around is having like a full disk image that forecasters may be able to like zoom in on certain problem spots. Like we could say we could highlight an area over the Amazon River Basin and say, okay, Sun Gland, and highlight the area over the Bahamas and specify the GLM false flashes caused by the Bahamas Bar or the inverse Bahamas Bar. Something interactive where forecasters can see where, when, and how these false flashes or false returns are occurring. So any feedback on that would be really good to have. And if you see any false flashes with the GLM or anything that just looks funky with the GLM, we would love to hear about it. You can always snap an image or an animation and post it to Twitter. You can tag me at Joseph Patton WX, or you can email me joseph.ray.patton@gmail.com. We can talk about that later. But if you see anything funky with the GLM, we'd love to hear it. And that way we can better prepare other forecasters for when those artifacts do pop up. So in summary, filters have greatly reduced the number of false returns that have been observed by the GLM. Knowledge of what common artifacts still remain can help reduce confusion for the users. More official training will be developed on this topic, so any suggestions are welcome. Eclipse season info can be found at the OSPO website at that link, and then also check out the GLM VLab page for more training and info that we've developed over the past few years. So with that, I will gladly take any questions or discussion, and thank you so much for having me again at the Satellite Book Club.
Thank you so much, Joseph, for an excellent presentation. I know I really enjoyed that, and seeing as how we have over 70 folks on here today, I know I am not the only one. This is definitely something that I really wasn't aware of. I remember that tweet from the Indiana false spike, a while back, and I never thought more about it. So excellent, excellent. So I'd like to encourage everyone to, please stay on for the discussion, and we'd really like those questions, feedback, comments from the field and from the field offices and regional headquarters, as Joseph just mentioned. And also there's going to be a feedback survey, which will be posted in the chat room, and we'd love you to fill that out as well. So in 2 weeks from today, it's taking a break next week, of course, for the Thanksgiving holiday, but we'd love you for join us on Thursday, December 2nd. Brett Borkhardt, a meteorologist at WFO Chicago, is going to discuss the 2020 Duratio event, and no doubt will be an excellent talk as well. So we'll also always encourage you to contact the Towers S team if you need any assistance with configuration of satellite products. And of course, their email addresses are there on the screen for you. And more information will follow in an email from the Towers S team as far as anything to do with that. So with that in mind, let's transition right over into some questions and feedback. And again, go ahead and submit your questions in the chat room, or indicate verbal in the chat room if you'd like to visit verbally as well, and we can certainly unmute you as well for that. I guess just to start off with, Joseph, I guess one question that came to mind for me is, you had mentioned that the false alarm rate, if you will, from this is higher from GOES 17, and I think you mentioned some other places that GOES 17 had a few more of these signatures show up. Is that just due to the geographic domains of the different satellites, or is an instrumentation error, or differences, I should say? Is there a reason that we know of that GOES 17 differs a little bit more?
Well, I think it's a combination of a lot of different factors. There are many different sources of false returns, as this presentation shows, and I think that ultimately it comes down to some of them just being slightly more prevalent with the GOES West GLM for whatever reason, whether that be the fact that the GOES 17 GLM has to do the yaw flips twice a year, or the fact that the GOES 17 has that trouble spot with sun glint over the Gulf of Mexico that's a little bit more prevalent than the GOES 16 trouble spot with the sun glint over the Amazon River Basin. And so I think it's just one of those things where it just happens to add up slightly more in favor of the GOES 17 GLM with each one of these different phenomena. And then that ends up manifesting itself as a significantly higher false alarm rate.
That definitely makes sense to me, and I kind of thought that might be the case, but I thought if we have the person that actually knows here, I may as well ask, so thank you. It looks like we're getting some comments and some questions coming in from the audience. Appreciate that, everyone. Dan Lindsay echoed that this is great information, Joseph. Really appreciate this talk, as I do as well. Walter Snell has a question for you, which is, would the strobe lights from jet aircraft show up as well?
I don't think so, because those strobe lights are not nearly, the brightness is not nearly intense enough to be resolved by the GLM. So you got to remember that the spatial resolution of the GLM at nadir is only 8 kilometers by 8 kilometers. So if you don't have some sort of event which the brightness would be able to be resolved by that grid space, then I don't think that it would necessarily be picked up by the GLM itself. And especially with some of this, like some of the smaller objects that pass between the instrument and itself, you think, well, those probably aren't 8 kilometers across. No, but they're much closer to the instrument. So the instrument thinks that they're bigger than they are. So I think that you have to think on a scale. You have to remember that the spatial resolution here, it's not going to pick up, like you can't shine, I hope you can't shine a laser pointer at the instrument and get false lightning to show up. But I think that that's not going to be an issue for using this instrument in day-to-day operations.
Yeah, thanks, Joseph. That makes sense to me. And I admit, operationally, I sometimes sort of forget about the resolution of some of these things, right? We get so into using them, and they're very useful, definitely. But sometimes understanding sort of what's behind the curtain definitely helps me out. And honestly, that's something that I forget about, is the resolution of these things sometimes and how it maybe compares to some of the things we're getting from the ABI as well. So that's great points. So another comment and a question that came in from Kevin Thiel, and he comments too, great talk. And then he asks, in your experience identifying GLM artifacts, could you discuss which types of artifacts you would expect forecasters to see most often in operations? A great question, very operationally oriented, of course. And so, yeah, any thoughts on that, Joseph?
Yeah, we tried to order this presentation in terms of how often they occur. And that's, I mean, it's not like a hard and fast rule, but generally speaking, this list from top being the most common to bottom being the least common are in a general order. We have seen multiple forecasters bring up example of the hot pixels, like, hey, what's going on here? And, I can go out and download data for weeks with all these different examples of sun glint. So I think that hot pixels and sun glint are something that forecasters are probably going to see, pretty often. And then I mentioned during the talk how a lot of forecasters in the US have also seen the Bahamas Bar or inverse Bahamas Bar, just because it happens to be occurring along certain subarray boundaries, which are close to WFOs. So, but yeah, I think those are going to be the most common ones. And then like you get the ones like, maybe a few times a year where you have that weird, like light up like a Christmas tree imagery that I showed earlier. So I think most commonly you'll see those hot pixels, sun glint, and then maybe the Bahamas Bar as well.
Yeah, thank you. And I was thinking about it, we talked about the lighting up like a Christmas tree one. Hopefully that's one that I would recognize that it is a false scenario. I have high confidence that I would, but it's really good to know what's going into that, what's causing it, like we talked about here, because I could see getting questions about that, from some of our more savvy sort of weather geek friends and followers on social media and things like that, even the WFO level. So I think being able to explain that's really important. And then sort of dovetailing back to the operational, the weather side of it, I really like Kevin's question there. And I thank you for sort of answering that, Joseph, because that was something I was wondering about too. And I was going to kind of follow on by asking, have you seen any instances of where these false returns have occurred in the vicinity of high impact or potentially high impact weather, where they were maybe harder to kind of pick out? Or is it that more often than not, a lot of times the ones that we see more often are sort of spurious one and done kind of things with low flash extent density that maybe it's not as much, that sort of an issue?
Yeah, I think I'm leaning towards the latter, and I think we're lucky just because bad weather isn't normally going on all the time. So I can't think of, like, off the top of my head, a good example where a high impact weather event was impacted by an erroneous or anomalous GLM flash. But I can tell you that, like, those rebound events that we showed at the very end, those are false flashes specifically caused by very intense lightning. So you may get a very intense short burst of lightning within a storm that could cause false flashes down radial, and those would be a rebound event, but they're quite rare. I personally, I mean, I don't go hunting for them all the time, but I personally have only seen that happen in GOES imagery twice, in the 2 or 3 years that would, or yeah, depending on 2 or 3 years of fully operational data. But I think that it's not some. I hope it's not something that's going to be impacting high weather events, but it's going to be something. It's one of those things that you see and makes you go, "Huh, hey, what was that little thing? What happened right there?" And I think it's going to be more about making forecasters have confidence in the instrument, have confidence in the instrument, knowing what the instrument's telling them, even if it's telling them something wrong. And then also being able to, if anyone from the public has questions, like with the bull lights, for example, people are going to see that bright flash of light in the sky, and you can say, hey, our bright flash of light in the sky detector detected that bright flash of light in the sky. And so, it's just one of those things that's a way to enhance the GLM tool in the toolbox and help forecasters use it better in operations.
Yeah, that absolutely makes sense to me. And, I hadn't thought about the confidence factor too, where, if forecasters see some of these features and then, ask, well, what is, is there something wrong with the instrument? Being able to explain them and retain that confidence in the GLM, that makes absolutely great sense to me. And I had not thought about that. The aspects of sharing some of this imagery and things like that, online and social media and things like that to sort of explain what is going on. I love that idea. And I think that could be, really useful as well. I want to pause just for a second, just to remind folks, go ahead. We've still got a couple of minutes here. If you have a question or a comment for Joseph to throw in the chat room, don't be shy about that. And I was going to follow on again with sort of a question that came to my mind, dovetailing back to, this idea that more often than not, as you said, this probably isn't going to be something that disrupts high impact weather events. One thing that did come to my mind was, some of these, and it's because I'm in a cooler northern latitude, right? I don't get a lot of lightning during the winter time, but occasionally we get enough steep lapse rates to generate, some lightning flashes, or maybe if we're really lucky, thunder snow. But I kind of wondered, it made me think two questions, I guess. Is it a best practice then sometimes, if you get just this one singular flash that, maybe could be a flash or not, to kind of maybe see if that fits the environment, or B, to maybe hold on that for a minute to see if you have more than one. And I guess maybe the follow-on but related question would be the inverse of that. The filters that are out there, are they filtering any low-grade singular flashes out that might occur in those sort of, marginally favorable for lightning type of environments?
Those are all really good questions. Let me answer the last one first by saying that most of the studies, like I started with, have found relatively high detection efficiency, definitely exceeding the 70%, goal, greater than 70% that was, put forth when they launched the instrument. That Bateman et al. Study found that it had as high as, 90, upper 90s in terms of detection efficiency. So I'm not personally worried that the filtering is going to be filtering out flashes, but there are certain things that you need to take into account, just like you would during any convective watch. You need to understand your environment. So, that's always a good first check. Is what I'm seeing from the observations, is that congruous with what I have, what the physical model of what's going on in the atmosphere that I have in my head while I'm on shift? And one way you can check that is by, analyzing environmental soundings or looking at model data to better, is there enough, would there be enough, convective available potential energy or any sort of, is there some sort of frontogenesis going on which could, increase mixing and lead to a lightning strike? And I think that those things, seeing those flashes, there's a lot of things that could negatively impact the detection efficiency. Some places in the central U.S. may not necessarily be as close to the nadir of the instrument as, say, for example, goes east is for the East Coast or for Florida. And so the resolution might be slightly worse there. And then in addition, especially during winter time, if there's clouds, if there's upper cloud decks blocking that flash of light from getting from the source of the lightning, the actual lightning strike, to the instrument itself, then if the instrument can observe that bright flash of light, and it may not necessarily be to have as high detection efficiency as, say, an example where you didn't have any upper cloud decks blocking that light from happening or that light from traveling to the instrument. So those are all things to consider. Would I expect, you can even ask yourself, if the GLM saw a flash, what would I expect it to look like? Would I expect it to have high? Would I expect it to be a large flash? Would I expect it to be a small flash? And those are questions you have to answer based on the environmental parameters. Now, I can tell you that I have seen the GLM pick up thundersnow. It has happened. So I have confidence that it has the ability to, but I don't necessarily have any numbers to support what kind of detection efficiency that would be.
Now that all makes sense to me, and great reminders about using sort of the total observation concept in our conceptual models. I have not seen thundersnow in person since the new GOES-R series came around, so something to look forward to, I guess, if we can get another big Colorado low up into my part of the world sometime soon. So I'll put out a last call to the audience for any questions that you may have, and in the meantime, our host Brian Gockel had a question or two. And one of them was, asking about the metrics of what percentage of GLM flashes are typically false, and you kind of talked about that. How is there any change in that over time that's been observed? I guess is sort of part of the question there.
Yeah, I think that's something that is going to continuously improve. We've talked about all the different filters which are being applied to get rid of things like hot pixels or sun glint. We saw that the filter that was applied for the Southern California solar farms reduced those false alarms from 2019 as opposed to 2020 and then 2021. And the data that was used for that Bateman et al. Study was from 2019 into early 2020. So I think that some of the more recent filtering, especially over the last year or two, has improved that false alarm rate and caused it to decrease. Some of them are still a little bit peskier than others to get rid of, and if you don't want to negatively impact the detection efficiency, like we've said, the fact that the GLM has a really high detection efficiency is a really good thing, and I think that keeping that is definitely a priority. So you don't want to remove any flashes which you know are going on, but it's a delicate balance, getting those to be happy with each other, detection efficiency and false alarm rate.
That definitely makes sense to me. Thank you so much. And I know we're getting towards the time where we usually end. Scott Rodolsky did comment that he has a follow-on to share if there's time. So if we have a minute, if someone wants to unmute Scott, if you'd like to share, I think we can do that.
Yeah, are you able to hear me?
Yep, we sure are.
Perfect. Yeah, great explanation, good presentation, Joseph. Really good to put all this information in one place. I just wanted to follow on in terms of your question, Chauncey, confirming a GLM event during, an isolated event like that. The ground-based networks are perfect for that. That's our recommendation, is to use those in conjunction with one another. I also wanted to mention it's probably less likely that an isolated flash like that will be missed by the GLM, except for the case that Joseph mentioned, if there's some high cirrus blocking it. Where we do worry a little bit more about it is in the intense convection. Are we getting all of the flashes? And so that's kind of the flip side that Joseph was just describing. And after we get this round of training done, we're going to really focus more on that, on where we might be losing some detection efficiency. And then one last point I wanted to add, going back a few questions to, can we expect to see some of these false signals near important weather or impactful weather? And we showed the rebound case. So that's one where you can have what looks like an appendage, and you might be interested, is that actually a bolt from the blue or something coming out of the side of the storm? And another time where that happens is low cloud illumination. So if you have a real tall convective turret and you have bright enough lightning in there, it can actually illuminate low clouds that are surrounding it. And so what we recommend you do in that case is look at the optical energy. And if there's an exposed channel coming out of the side of the cloud, it's going to be extremely bright. And if it's low cloud illumination, it'll be very dim. And so that's just one of those things where we have these 3 different gridded products for a reason. And once we get people familiar with using them, the other 2, in addition to flash extent density, can really help to nail down what might be the source of the light you're seeing. So that's all I had.
Thank you so much, Scott. I really appreciate that, and great reminders about comparing with the ground-based network, which I know we do in real time, as much as we can anyway, and then about the other products too. Absolutely. Thank you so much for chiming in there. So I think, unless I missed any, that kind of summarized all the questions that we had from the crowd. Joseph, I don't know if you have any final comments to make before I turn it back over to Brian, I believe.
Yeah, I just wanted to say thank you so much, Scott, for those points. Those are something I always try to hit on for every GLM talk, is that you have to use all of the data in front of you, including GLM, ground-based lightning networks, for lightning data, and, synthesize that all together. So thank you, Scott, for that comment. And yeah, I think that's pretty much all.
Excellent. Well, thank you so much, Joseph. I really, really enjoyed and got a lot out of this presentation and our conversation afterwards. And I'll turn it back over to Brian now for some final remarks.
All right. Thank you, Chauncey, for moderating today's seminar. And thanks again to Joseph for your informative presentation, bringing this forecaster community closer to the GLM product, helping us recognize and not be tripped by false flashes. We also very much appreciate being joined by Steve Goodman, Scott Rodlowski, Dan Lindsay, and the other GLM scientists, real movers and shakers in the field who have labored for years to bring this instrument and product to us. So thanks for their participation. As Chauncey advised us, we'll be on holiday in Thanksgiving week, so we'll join you in 2 weeks. Look forward to your participation. Brett Burchard will be talking about the 2020 derecho, another talk you won't want to miss. On behalf of Office of Obs, our GOES-R partners, TowerS team, Chauncey and Joseph, we all want to thank you for your participation today. Wish you a good holiday and see you back here in 2 weeks. Thank you very much. Have a great day.